Look at question number 3 from the team selection test, and it was a combinatorics question. And the idea was that there was some form of a rectangular grid which was colored in a checkerboard fashion. Okay, and it'll sometimes say checkerboard, sometimes it'll say chessboard. But the whole idea behind a chessboard or a checkerboard is essentially that you have a rectangle, and in this rectangle, there's alternating squares, and the alternating squares are always the opposite color. Okay, so we can just assume, like, it doesn't kind of really matter that much. We can assume that this top left color is black, and then this must be black, and this is black, this is black, this is black. But the idea is that they're alternating in color. This is how a chessboard looks like, or a checkerboard. And so the idea is that we have numbers in each of these cells. So we might have like 1 here, say 3 here, or 2 here, or 5 here, 7. So no, there's different numbers, and there's many, many possibilities. But the idea was that the sum of the numbers in each row, and the sum of the numbers in each column is even. And we want to prove that the sum of all numbers in the black cells is even. So what we have that this column is even, 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 this column is even. And again, we also have that this row is even, this row is even, this row is even, and this row is even. And we want to show that the sum of all the cells in this one, black, 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 like all of these, the sum is also even. Now, what we might think of doing is saying, okay, well, what if I take this row and add it to this row, and add it to this row, and add it to this row? So I add row 1 to row 2 to row 3 to row 4. If I add them up, row 1 plus row 2 plus row 3 plus row 4, well, the sum of 4 even numbers is still even, right? So that means I actually can prove just like that the sum of the numbers in all cells is even. And I could have done the same thing. I could have taken like this 5, 6, 7, 8, 9, 10. And so I could have, again, instead of said number 5, dot, 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 up to number 10, well, that would again be all these cells. So I have two ways of showing that the sum of the different cells, the sum of all the cells is even, but this is not what I want. I want to show that some of all the numbers in the black cells are even. So how do I get to the black cells? And the problem is, as soon as I take any given row or any given column, then I just end up like getting all the white things in there as well. And so I kind of want to find a way to get around that. So I'm going to do something a bit like tricky. So what I'm going to do is I'm going to count this row. So I'm going to look at row 2, okay? And then I'm going to also include row 4, okay? And I've kind of got half of my black cells, but I don't have the ones in rows 1 and 3. But what I'm then going to do instead is I'm going to take column 10 and column 8 and column 6. Okay, then what happens is, how many times have I counted this black cell? Well, I've counted it once because I only counted in 10. And how many times do I count this one? Well, I count it once because I only counted in column 8, and I count this one exactly once, right? And then I count this one also once because I only counted in row 2. I count this one once, and I count this one once in row 2, in row 10, this one, in row 8, and in row 6, and then again in row 4, sorry, column 10, 8, and 6, and row 4s. So I end up counting all the black cells exactly once, but then I double count some extra. I double this. This is equal to the black cells plus some extra white ones. The extra white ones, though, are the ones that are in columns 2 and 4, sorry, rows 2 and 4, but in columns 10, 8, and 6. There's this one over here, I'm going to call it A, and this one here B, and this one C, and this one D, and this one E, and this one F. They get counted twice. So this 2 plus 4 plus 10 plus 8 plus 6 is actually black cells once plus 2 times whatever is in A plus B plus C plus D plus E plus F. Right? So that's the idea. So I'm getting my black cells, but I'm also getting double this. Now this is even. Like everything in row 2 is even, everything in row 4 is even, everything in column 10, column 8, and column 6 is also even. So this is the idea. This whole thing is even, right? And this whole thing here is obviously even, right? But then if I take this big even number and I subtract this other even number, well, then I get another even number, which is just the sum of my black cells, right? So the sum of my black cells plus an even number is another even number, which means that the sum of my black cells must be even. So this must be even. So what did I do here, going back to the logic? Because I arbitrarily chose this like 4 by 6 square, but it can work for any rectangle, really. The idea is I choose alternating rows, and then I chose columns where the intersection between those columns and the rows that I previously chose were actually only the white cells. So I again did alternating rows and alternating columns where the intersection of those alternating rows and those alternating columns was white. Because then I would double count the white cells, those intersections, I'd count them twice, but counting twice is okay. So that's the idea. I take alternating rows, so row 1 and row 3. If there were more, I could take row 5, I could take row 7, I could take row 9, etc. But then I make sure that I choose columns. So here I chose columns 10, column 8, column 6, such that the intersection between row 1 and this, sorry, I wasn't supposed to choose row 1, I was supposed to choose row 2 and row 4 and row 6. But the idea is that the intersection between row 2 and column 10 is a white cell. And the intersection between row 4 and row 10 is also a white cell. So I double count the white cells, but I make sure I count all of the black cells exactly once. So that's how to solve this problem. And this method works for any type of rectangular grid. I'll leave you to write up the solution yourself. You're welcome to send it to me to check up your solution if you like. But thanks. Let me know if you have any questions.